We're going to begin with section 4.2, which is a binomial probability distributions. Okay, so a probability distribution, as you learn, guys, you have x values, possible x values in one column and probabilities in the second column, and each probability has to be between 0 and 1, and the sum of all probabilities must equal to 1. What is a binomial? Binomial means 2. 2 in our case is going to be success or failure. Let me tell you what a binomial probability distribution is. The following conditions must be met in order for an experiment to be a binomial. The experiment is repeated a fixed number for a fixed number of trials. So you cannot do the experiment forever. You have to do it for a fixed number of times. That's number one condition. There are two outcomes from the experiment, either a success or a failure. So you can't have, you cannot like ask a person a question and give him 3 choices. It's only 2 choices. Either you are successful or you're gonna fail. And condition number 3 is the probability of success does not change from one trial to another. So if you do 10 trials, the probability of success will remain always the same. And your random variable x counts the number of successful trials. So let me give you an example what a binomial experiment is. Here's an example. Please pay attention to this. I'm just gonna put it here. I'm gonna roll a die. That's a die. I'm gonna roll it 10 times. So that's a fixed number of trials, guys. We're doing it only 10 times. That's condition number 1. You would win if the die lands on a 6 face up, and you lose if it doesn't. So what's the probability of success, guys? And what's the probability of failure here? What's the probability of being successful? Who can tell me what's that probability is? You win if you get 6 face up. Do you guys agree it's 1 out of 6? Because there are 6 faces, and if you get 6, so 1 out of 6. Who can tell me what's the probability of failure here, that you lose the game? Yes? If your chance of success is 1 out of 6, what's the chance of failure?
5 out of 6.
5 out of 6, yeah. So here's condition number 1. We did a fixed number of times. That's checked. Condition number 2, we have a probability of success or failure only. You either win or lose. That's it. And the probability of success, guys, every time you roll a die doesn't change. It's always 1 out of 6. So that's condition number 3. Okay. So probability of success doesn't change. It's always 1 out of 6. And probability of failure doesn't change. It's always 5 out of 6. If I want to list the number of successes, if you do an experiment 10 times, guys, can you help me list the number of successes? And this is called X, the random variable. Is it possible, guys, that you roll a die 10 times and you don't get 6 face up, so you don't win at all? Is that a possibility? Is it possible? Yes or no?
Yes.
Yeah, it is possible. I mean, unlikely, but it is possible. So if you play this game 10 times, guys, there is a chance that you would lose. You will win. You wouldn't win at all. There is a chance that you win 1 time, or 2 times, or 3 times, or 4 times, or 5 times, or 6, or 7, or 8, or 9, or 10. These are the possible values of the random variable. X, guys, is the number of successes, as you notice right here. You see, the number of successes. The number of successes, guys, always starts at 0 and ends at the number of trials. And since I said we have 10 trials here, so look, X could be as low as 0 as high as 10. So, but the probability, guys, that you will not see a 6 at all is very low. It's going to be very low. You probably get a 6 while doing the thing. And the probability that you get a 6 10 times, I don't think this is going to happen. It's going to be very, very low probability, but it is possible. I mean, we could win the lottery, the jackpot. So these are the possible values of the random variable. And this is an example of a binomial experiment. That's what a binomial experiment is. Okay. Okay, let's see this example and see if we have a binomial experiment in this example or not. Number one, a certain surgical procedure has a 95% of success. So the chance of success, guys, is 95%. Can you guys tell me what's the chance of failure here? If you know the probability of success, you should know the probability of failure. Oh, 85%, sorry. So what would it be for failure, guys? Can a student mention that? We can put it in the chat. 15%, yes, I agree. Okay. A doctor performed the procedures on 8 patients. So the number of trials is 8. That's condition number 1, guys. That's condition number 1. We do it 8 times. That's condition number 2. There is a probability of success and there is a probability of failure. The random variable represents the number of successful surgeries. Well, the number of successful surgeries, guys, it will be either a 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. And this is a binomial experiment because we have a fixed number of trials. We have a probability of success and probability of failure. And they didn't tell us that the probability of success will change from one patient to another. It's the same. They say he has 85% of success, regardless of who the patient is. So this is an example of a binomial experiment. Yes, binomial experiment. It is very unlikely, guys, that the doctor will perform the surgery and 0 patients will have successful surgery, but it is a possibility. It's one of the options. Very, very low probability that this will happen. Number 2, a jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select the 3 marbles. So n equals 3. We're doing the trial for n is the number of trials. So n is 3. Without replacement, the random variable represents the number of red marbles. So if you get a red marbles, you are a success. You have success. What is the probability of success, guys, when you pick 1 red marble at the very beginning, the first draw? I have, let's see how many in total. I have a 5, a 9, that's 14, and a 6, 20. Okay. What is the probability of getting a red marble, guys? I have 5 of them, so it will be 5 out of 20. So that's the probability of selecting a red marble at the very beginning. But he says you're doing the trial 3 times. In the second time, he says without replacement. You know what without replacement means? Means you don't put the marble back that you selected. If it is without replacement, guys, and if I want to figure out what's the probability of selecting another red marble, it's not going to be out of 20. It's going to be out of 19. And it's not going to be 5 anymore. It's going to be 4 out of 19 because I didn't put the marble back. In this case, guys, you notice that the probability of success is changing from one trial to another. And when the probability of success changes from one marble to a trial to another, it's not a binomial experiment. not a binomial experiment. So anytime, guys, you see the word without replacement in any trial, you know that the experiment is not binomial experiment. Okay, so that should, if you toss a coin, guys, 10 times, that is a binomial experiment, because the probability of success, let's say if you get a head face up, you win. That's 50-50. It doesn't change, just from one toss to another. So that's a binomial experiment. But this is a situation here, guys, where you notice that it is possible that it can't be a binomial experiment. And you see, I bolded the expression without replacement. If I put with replacement, then it will become a binomial experiment, but that's without replacement. Okay. So what we're gonna learn, guys, in this section, how do you find the probability of having 0 success? How do you find the probability of having 1 success, 2 successes, 3, 4, 5, 6, 7, 8? And if you find all those probabilities, if you add them up, you're going to add up to 1 always. You're going to learn how to use technology to find those probabilities. That's actually the main goal of this section. So if what's the probability that the surgeon is going to perform the surgery and 3 out of 8 of those patients will have success? We'll figure this out. 4 out of 8, 5 out of 8 will figure out all those probabilities. Okay. Let's begin with this example. So from now on, we're going to assume that the probability distribution is a binomial probability distribution, and then we'll be asked to compute probabilities. Microfracture knee surgery has 75% chance of success. The success probability in this book, guys, is called P. So P is called the probability of success. And the Q, guys, is called the probability of failure. And if there is a 75%, guys, chance of success, there is 25% chance of failure, because the probability of failure plus probability of success should add up to 1 always. So I'm going to write it down here. P plus Q is always equal to 1. N is the number of trials. So he says the surgery is performed on 3 patients. That means N is 3 in this example, guys. And X is the possible values of the random variable. And since N is 3, guys, I can tell you what X is going to be. You start with 0, and then you go 1 or 2 or 3, up to the number of trials. So P is 0.75. Q is 0.25, N is 3. That's what you need to know. And actually, when you use technology later, you don't even need a Q, you just need N and P. Okay, are we good so far? So probability of success is 75%, and we're performing the surgery on 3 patients. And let's see what the question is. Find the probability that the surgery being successful on exactly 2 patients. So he wants the probability of success on 2 patients right here. X equals 2. So he wants the probability of X equals 2, guys. I could ask you what's the probability that no patients will have success. So X equals 0. I could ask you what's the probability that 1 patient will have successful surgery only. That's X equals 1. And I could ask what's the probability that the surgery will be successful on all 3 patients, then will be X equals 3. And if you add up all those probabilities, guys, they should add up to 1, because the sum of probabilities is always equal to 1. Now, the probability of exactly X successes in N trials, there is a formula, guys. I'm going to show you how to use this formula by hand, but after this, guys, we're going to go to the calculator and show you how this formula is built into the calculator. So that's the highlight of this chapter, this formula that will compute the probability of exactly X successes. But let me show you how to interpret this formula. When you go to help me solve this in my lab statistics, he's not going to show you how to use the calculator to do this. He's going to show you this formula. So if you already know how to do it, just with me and we did the practice, you don't even need to go and check, view an example, because it's just going to show you how to use the formula. You guys, you need to mute yourself, please. All right. So, N, guys, we decided it is 3. X, we want the probability of success on 2 patients. And P is 0.75. That's the probability of success. And let me show you how to use this formula. And I'm going to show you how to enter it on your calculator screen. Okay, it says N choose 2. Remember, we did that in chapter, N choose X. We did that in chapter 3. So 3C2 times P, which you already know, guys, which is 0.75, raised to the power of X. What is X here? It's 2. Times Q. Q is the probability of failure, and we decided that Q, guys, is 0.25. And raised to what power? N minus X, which is 3 minus 2. And let me show you how to do this on your calculator and find the probability. All right, ready? So first of all, guys, put 3 and choose 2. If you remember, you go to math, and then you go to probability, and look, this is the NCR, and then I need 2. Enter this and put 2. If you want, you can get the answer first, which is 3. So now we have 3 times, and now let me just show you the rest of the screen. 0.75 raised to the power of 2. And look, this is the exponent, guys. This is for exponent right here. Oh, you don't see it. Just let me raise it right here. 2. And now to go back, just to the line, you just press this key and then times 0.25 raised to the power of 3 minus 2 is 1, guys. Okay, I can still raise it to the power of 1 just to show you how that works. And here's the answer. 0.421875. That's the probability. So I put the answer. Now, guys, if I ask you to round this one to 3 decimal places, you will get 0.422. If I ask you to round it to 4 decimal places, it will be 0.4219, and so on and so forth. If I ask you to round this answer to 2 decimal places, it will be 0.42. And this formula is built into the calculator. We don't have even to enter it the way we did, but this is how we begin with this. Let's practice and see. Let's say I give you this question on the test, and I say, what's the probability of the surgery being successful on exactly 1 patient? 1 patient only. So the only thing that's going to change, guys, is X. X is going to be 1. So probability of X equals 1. So Q here is 0.25. Let me just do this on the side. Probability of surgery successful on 1 patient only. Guys, you need to mute yourself, please. I'm recording here. Okay, probability of surgery is successful on 1 patient only. So X is 1, guys. So we need a probability of x equals 1, which is, according to the rule, 3, choose 1. You see, NCX. P is 0.75 raised to the power of 1. Q is 0.25 raised to the power of 3 minus 1, which is 2. And let's see what the calculator gives us as an answer. You put 3, and then math, and then you go to PRB. Oops, sorry. And then NCR, and that's a 1. And you want to find the answer, we can do it. It's a 3. So just put 3 here times 0.75. You don't need to raise it to the power of 1. It's 0.75 times 0.25 raised to the power of 3 minus 1, which is 2. You can put 0. If you want, guys, you can do this. 0.25 times 0.25. And which is 0.1406. And that's the probability of the surgery being successful on exactly 1 patient. Okay. Let's say I ask you what's the probability that this surgery 0 patient will be successful on no patients at all. So probability of x equals 0. And if you want to use this formula, so your x is 0 here. So it will be 3, choose 0, p raised to the 0 power, and q raised to the power of n minus 0, which is 3 minus 0. And then you can do the math to figure this out. So you can do 0, you can do 1, you can do 2, we cannot ask of any numbers beyond those 4. They have to be limited to 3 and less always. There's no question that to tell you what's the probability that the surgery will be successful on 4 patients, because I only have 3 patients where I'm gonna get the 4th one from. So that wouldn't work there, okay? All right. Now we will show you how we're gonna use calculator, the programs that built into the calculator to do binomial distribution. There are a couple nice programs, guys, you're gonna like them, built into the calculator that will compute, answer all those questions, okay? So let's pay attention to this and see how we're gonna proceed from here. The results of a recent survey indicate that 67% of US adults consider air conditioning a necessity. When you begin reading, guys, the first percentage he gives you, that's a probability of success. So that's P, which is a probability of success. If you randomly select 10 adults, that's your N, guys. So N is 10. All right. What is the probability that exactly 7 of them consider air conditioning a necessity? Use a technology tool to find this probability. So exactly, guys, we agreed when we review for algebra means equal. So here's how you write it down. Probability of x equals 7. You write it down like this. That's the first question that you're gonna hit by when you start doing section 4.2, guys, exactly. Okay. Before we do this, we could use this formula if we want. Put x equals 7 here. And then n is 10, guys. So it will be 10 choose 7, and p is 0.67 raised to the power of 7. And q, 1 minus 0.67 will be 0.33 raised to the power of 10 minus 7. But you're not going to have to go through this. You're not going to need to do any of this because this formula is already built into the calculator. So for exactly, guys, when you see the word exactly, there is a formula that's built into your TI-84 that can handle anything that has to do with exactly only. So once it says exactly, I'm going to show you the formula. You're ready? All you need to know what the probability of success is, what n is, and what he's asking for. He's asking me for probability of x equals 7. Even if he asks a probability of exactly 6 of them, I can do it. 5 of them, 4, 3, up to 10, we can do it with this formula. So here's the formula, guys. You go to second. Let me show you the second, and then distribution right here. So second, to access the blue function, guys, you have to press the second key and variable. And then I would like you to scroll down. If you can do it with me while watching me doing this. Binomial Pdf, this one. And press enter. Okay. It's asking me, so that's the function, binomial PDF. It's asking me for the number of trials. Can a student tell me how many trials do we have in this question? What's the number of trials, guys? Yes?
10.
10? Thank you. What's the probability of success?
5.
I heard, which is 0.67. Change it to a decimal. You must change it to a decimal. What is he asking for? What's the X value that he's asking for, guys? He's asking for 7. So I'll put 7. And paste. Now, some students might not see this window on their calculator. I'm going to show you what to do. You're going to see, some students will see this window, binomial PDF, and it will open parentheses for you. So you will enter. First thing, you enter the number of trials, which is, you don't have a choice of doing it in other order. So first of all, you will enter the number of trials. Then you will enter comma, followed by the number, the probability of success, comma, followed by the X value in the question, and then you should get the answer. Watch, guys. 0.26. Okay. Well, on the assignment, guys, when you do the assignment for me next week, this is how I like you not just to write it down. I like you to do binomial PDF, and I like you to put the 10, the comma 0.67, comma 7. I don't want you to show me the direct instruction how you did it on the calculator. Just give me the final answer. Usually to 4 decimal places, so it will be 2614. Okay, guys. So that's how we use the technology for exactly. Let me change this question and make it, what's the probability that exactly 3 of them consider air conditioning a necessity? Okay, look what you do, guys. Let me clear this. You go to second, distribute, binomial PDF. It's a binomial probability density function. Number of trial is 10. The first 2 don't change, guys. From one question to another, they will not change, never. The only thing that you have to change the X value is 3. I said, what's the probability that 3 of them consider air conditioning a necessity? And paste and enter. There you go. That's the probability. What about if I ask you what's the probability that all of them consider air conditioning a necessity? Okay. There is a way, guys, to bring this formula back without having to go through the whole thing one more time. Look, watch. Not many people know about it. So if you press the second and then enter, you get the formula back. So can someone tell me what do I need to change here? What do I change? I said, what's the probability that all of them consider air conditioning a necessity? So guys, you agree with me that I need to replace the 3 with what? With 10. Okay, which is 0.0182. I could ask you what's the probability that none of them will consider a conditioning a necessity. So it's a probability of x equals 0. So you guys, if you press the second and the enter key, you get the formula back. Just go back and change. And guys, I need participation. I could mandate this on you because that's a part of the grade that students will participate with me in the class. I mean, I could finish this lesson in 20 minutes if students are not participating, but I don't want to do that. It will help you when you participate and you won't forget, just what you say to me next time. So binomial PDF is 10, comma 0.670. And this is a question when he asks what's the probability that none of those people say, none means 0, say air conditioning is a necessity. And let's find this probability. Okay, you can see the E-5, guys. E-5 means you have to move the decimal 0.5 digits to the left. So your answer is going to be 0.0000153,157, etc., which is a very, very low probability. Okay. I could ask you to find the probability of x equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that will form the entire probability distribution. Okay. Another question in the book, in the homework online, which I'm going to show you right now. Just put it right here before I proceed to the second question. It will give you the results of a recent survey indicate that 67% of US adults consider air conditioning a necessity. If you randomly select 10 adults, construct the probability distribution of this. Construct the probability distribution means, guys, you have to do this. X, Px. We know the possible values of x. X is the number of successes. It could be as low as 0 all the way to 10, guys. 8, 9, 10, all the way through. Okay. Well, guys, I'm not going to have you go to the formula on the calculator and find 0, probability of x equals 0 first, probability of x equals 1, probability of x 2, just like we were doing, and then probability of x 7, 8, 9, 10. There is a shortcut that I can show you right now, and you can do it, to find all those probability in one shot. And let me show you how to do that. Okay, does anyone know how can I use the binomial PDF formula that we're using that to find the probability of x equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way in one shot rather than doing them separately? Knowing the calculator, do we have any suggestions, guys? How would you do that in one shot? I asked this question in class, and it happened that sometimes I have a student who knows how to do that. The formula requires that you enter the value of n, you enter the value of p, and you enter the value of x. Do you guys can think of a way? When I first did it, I just thought of it myself, and I said, let me try this, and it worked. And I was able, to produce all the answers, guys, in one shot. What would you do? Any ideas? Yeah, you can use the formula always, because that's what's built in the calculator. The binomial PDF that I'm using right now is exactly, just the formula that you are using. But for this question, I wouldn't think that it's good to use the formula by hand, because I need, just 10 probabilities or 11 probabilities from you guys. So let me show you how we can do all the probabilities, find the probability of x equals 0 and 1 and 2 and 3 and 4 and 5 and 6 and 7 in one shot. Watch, guys. Go to stat, edit, go to L1 and make it, enter all the values of x. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's the first step. I'm gonna just delete L2 so it doesn't confuse you. You will see, you're gonna like this. Let me just do one more thing here. Okay, now guys, watch. Go to second and variables, go to Binomial Pdf. Okay, number of trials is 10. Probability of success is 0.67. Who can tell me what should I enter here in order to get everything? You should know now. Come on, guys. I want all the probabilities from x equals 0 to x equals 1 to x equals 2 to x equals. So what should I put here? Where did we put the numbers? We store them in a list called L1. So we're just gonna enter L1 here and watch. And paste. Watch, guys. Ready? Enter. There you go. Look at the values. The first one is probability of x equals 0. The second one is probability of x equals 1. The next one, probability of x equals 3, x equals 4, x equals 6, x equals 7. It's coming. That's the one we did earlier, and so on. You see this 2614, x equals 7. Then x equals 8, 0.1990. X equals 9, 0.0898. And the last one, guys, 0.0182, which is probability of x equals 10. So you can get them all in one shot using this formula. You put the x values in L1 and you just run the binomial PDF on L1. That should give you everything. Any questions about this? So just put the x values in L1 and here you run binom PDF. You put the value of n, which is 10. You put the value of probability of success, which is 0.67, and you put L1, guys. And you should have the answers for all at once. Okay. B. Let's go to the next one. What is the probability that at most 7 adults consider air conditioning a necessity? Now you guys understand why I went through at most and at least and all those inequalities, because as you can see, they're popping up in here. At most 7, guys, means less than or equal to 7. And can you guys tell me what are the possible values of x that are less than or equal to 7? We just did it earlier at the very beginning. Remember, these are individuals, 10 adults. You cannot have decimals. They are all whole numbers. So it could be a 7 or 6 or 5 or 3 or 2 or 1 or 0. Here's how you can do this one, guys. You can use the binomial PDF to find probability of x equals 7, then use it to find probability of x equals 6, then use it to find probability of x equals 5, then do it for 3, then do it for 2, then do it for 1, then do it for 0, and then add them up, because OR means addition. And I already showed you a way you know how to display all of them in your calculator. So you just get the answers and add them up. But for at most, guys, there is a built-in formula on the calculator that takes care of at most. So anytime you have an at most question, there is a calculator that instead of you going and finding probability of x equals 7 and then 6 and then 5 and then 4 and then add them up, the calculator will do all the work for you. And let me show you this one. So only for at most. Binomial PDF is reserved for exactly. And for at most, guys, you're going to see this formula right here. I'm going to write the name of it, which is Binomial CDF, cumulative. C stands for cumulative. Okay, let me show you this formula. Second, distribute. You see it right after binomial PDF. These are the only two formulas in section 4.2 that you need to learn. So CDF. So the first one for exactly is reserved for exactly, and the second one for at most. Enter. Number of trials is 10. Probability of success doesn't change, guys, 0.67. The X value, we need 7 or less. Is that what it says? Okay. So what this formula is going to do, guys, it's going to find the probability of X equals 7, and then 6, and then 5, and then 4, 3, 2, 1, 0, and then add them up. We don't have to worry about what's going on in the background. And then hit paste and enter, and you get the answer. 0.6930. Now, probably you'll ask me a question, why your answers are shown with 4 decimal places. This is what I did, guys. I went to mode, and you can see here, I changed this number to 4. So for this chapter, it will be safe to do that because most of the questions it will ask us to do into 4 decimal places. So if I quit, and that's the answer. So you put 10 first, this is 0.67, and then 7, and then you put the answer 0.6930. So if I go back and show you what I did earlier, guys, when we did this, second and distribute, let me just do that. We did 10, we did 0.67, we did the X value, which is L1, that's what I put there, and then hit paste. Okay, so if I do this, guys, let me go to the very beginning. Okay, this is X equals 0. If I add this is X equals 1. This is probability of X equals 2. This is probability of X equals 3. If I add the 0, the 1, the 2, the 3, the 4, the 5, the 6, the 7 all together, guys, I must get this, exactly this, 0.6930. So the binomial CDF will save you, just time and the efforts to do that, and will do it for you. And that's what binomial CDF is reserved for. Rather than doing all that work and add them up, it's all done right here. So I'm gonna go very slow with this question, guys, because this is pretty much it, just in this section. So for exactly, we use binomial PDF, and for at most 7, we use binomial CDF. Now, I want to show you something really nice online that you can use as well to find those binomial probabilities. Let me pause the recording for a second. So we're using StatCrunch right now. You log into StatCrunch, you go to Stat, Calculators, Binomial Calculator, and then you enter the value of N, you enter the value of P. These are fixed, they don't change, probability of success. And then you answer the question. The first question was, what's the probability of X equals 7? I just changed this to 7. And make sure to hit compute, guys. It won't do it until you hit compute. Now, part B, what's the probability that at most 7? We agreed, guys, from algebra that at most means less than or equal to 7, and look at the answer. It's already displayed for you. Who can guess what the answer is if I say at most 10 of them? You should know what the answer is going to be. At most 10 means 10 or 9 or 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. Everybody add it together. What do we know about the sum of all probabilities must equal to what, guys? Always 1. Look, it is 1, everything. If I say at most 3, look, guys, just change it to 3. And here you go, that's the answer. If I say none of them, just put a 0 here, equals 0. And look how nice it is. So you can use this one to help you as well, guys, for computing the answer. Not only it will give you a really nice answer without the E here when you use the binomial calculator that is built in StatCrunch. So if I say what's the probability of X more than 7, which we're coming to this in a little bit. More than 7, guys, means 8 or 9 or 10. You can use a binomial PDF on 8 and on 9 and 10 and add them up, or you can do it in one shot, just like here. More than 7, greater than, like this, and put 7. And watch, guys. Sorry. There you go. And look what it did. It did 8. You see what's marked in red is what the calculator took into account here, the 8, the 9, the 10. It found the probability of 8, probability of 9, probability of 10, and add them up. Let's say less than 4. We just do this. And you guys agree with me, less than 4, it's going to be the 3, the 2, the 1, the 0. Watch. Hit compute. Look, 3, 2, 1, 0, all the way here. It found the probability of each one, add them up, and give you the answer. And you can see I'm not changing anything. You can use this for in between. If he says like X is between 4 and 7 inclusive, you just put 4, 7, and hit compute. Look, it counted 4 and 5 and 6 and 7. Found the probability of each, add them up, and gave you the final answer. So this is how you use the binomial calculator. Not only you can use it in StatCrunch, guys, I'm just going to show you that you have a lot of options for the binomial calculator. If you just Google binomial calculator, and here you go, there is one. You see the formula, guys, that I used? That's the formula. That's the highlight of this chapter. Here is another one. You just enter probability. Okay, the probability of success is 0.67. Number of trials, you have to enter that 10. And then number of successes, let's say 7. What's the probability of X equals? And see now, guys, calculate is going to give you everything related to 7. This is the probability of X equals 7. This is the probability of X less than 7. This is the probability of X less than or equal to 7. This is the probability of X greater than 7. And this is the probability of X greater or equal to 7. And you choose. If this is your question, like part A, that was the question. I just picked this answer only here. Okay. So you have a lot of options and resources to make use of when using your calculator. Okay, I'm just going to go to my screen and go to part C. What's the probability that more than 7 adults consider air conditioning a necessity? How would you do? More than 7, guys, means this. That's more than 7. Okay, who can help us answer this question? Okay, I have the variable 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, guys. More than 7 means what? Means this, or that, or that. 8, or 9, or 10. Any idea, guys? How would you do it? Any ideas? Just make me feel that you're listening to me, guys, and suggest something. I kind of feel that I'm talking to myself when no students respond to me. Yes? That would be one way to do it, but I'm going to show you another way as well. So here is one way. I'm just going to put it right here. For part C, probability of X greater than 7, but I don't recommend this way, but I have students who do it this way. That means the probability of X equals 8 plus probability of X equals 9 plus probability of X equals 10. And then you use binomial PDF on each one. And just to use binomial PDF on each one, guys, watch. You already did it, actually. So I go to second, distribute. So 10, 0.6. Okay, I'm going to just do 8 first, just to show you one at a time. Okay, that's 0.1990 plus. Let's do the other one. And now I'm going to change it to 9. 0.0898. And then we're going to change it to 10. Okay, plus 0.0182. And just add them up. That's one way to do it. The reason why I don't recommend doing it this way, what about if n was 15? And then greater than 7 would mean 8, 9, 10, 11, 12, 13, 14, 15. You'll have to add them up. I mean, you could, and you still get the correct answer, but it's a lot of work. So I'm going to show you a shortcut in a second. But for the sake of what we did, just to get the final answer, if you use the binomial calculator that we did showed you online, it's going to do it in one shot for you. So it's 0.3070, and that's the answer. But the problem is when you take the test on campus, this binomial calculator would not be available to you. But just to show you how we could have done this using the binomial calculator on the okay, let me show you the binomial calculator one more time. Okay, 0.67. And the question was, what's the probability of X greater than 7? Watch, guys. Compute. And look, 0.3070. That's exactly what I got on the screen. Okay. Let's go back. Just let's share again. All right. So here is a shortcut, guys. Please pay attention to the explanation here. Okay. We need 8, 9, and 10. And we don't need 7, 6, 5, 4, 3, 2, 1, 0. But guys, 7, 6, 5, 4, 3, 2, 1, 0 means at most 7. That's at most. 7 or less means at most 7. And we already done that in the previous question, at most 7, which is we know 0.6930. And guys, you have to understand that the sum of all probabilities is equal to 1. So if I know this side, which is 0.6930, I can tell what remains, for the other side. It's 1 minus, because they should add up to 1. So if you do, guys, 1 minus 0.6930, you were going to get this one, which is a 0.3070. So when he gives you probability of x greater than 7, here's what you can do. You can do 1 minus Binomial CDF always. And I'm going to write those summaries at the bottom once we're done. CDF. And you put n, which is 10, 0.67, and put 7. And it will be 1 minus. It happened that we did this in the previous question, and that's going to be 0.3070. So you have two choices, guys, to do more than. You can do it just like what I did here, list all the items that are more than 7 and find the probability of each one and then add them up. Or you can do 1 minus binomial CDF on 7, 0, 10, 0.677, and then you get the answer. Okay. D. What's the probability that at least 7 of them consider air conditioning a necessity? Do you guys agree that at least 7, we write it like this? That's at least 7, greater than or equal to. And what are the numbers that are at least 7? Can someone put them in the chat? What would they be? If you can list them for me. So
0, 1, 2, 3, 4,
no,
5, 6, 7.
at least 7. That's the other way around.
7, 8, 9, 10.
Exactly, 7, 8, 9, 10. And you guys, you can find the probability of x equals 7. You can find probability of x equal 8. You can find probability of x equal 9. You find probability of x equal 10 using the Binomial Pdf and add them up. That's one choice. Or let me show you the alternative choice, which is a shortcut. Okay. At most 7 is what you said, 0, 1, 2, 3, but at least 7 means 7, 8, 9, 10. That's what we want. The 7, the 8, that's what we're asked to do. And what are the remaining values of the variable? I'm going to list them here. Zero, 1, 2, 3, 4, 5, 6. That's what we don't want. So he's asking me for probability of x equals 7 plus probability of x equal 8 plus probability of x equal 9 plus probability of x equals 10. He's not asking me for this. But guys, I can find this. That's 6 or less. That's at most 6. And the reason why I said I want to find, this is not what he's asking me for, but I can find it because it's at most 6. At most 6 means 6, 5, 4, 3, 2, 1, 0. If I find this, because I have a formula, the binomial CDF will allow me to find at most 6. Once I find this answer, guys, I can subtract it from 1 to find the remaining answer. So this is going to be, guys, 1 minus binomial. And again, if you ask me why you're doing something he didn't ask, because I have a formula that would allow me to find the utmost. So 1 minus binomial CDF 10, 0.676. And this answer, whatever this answer is, guys, I subtracted from 1 to get the remaining, just probabilities. So that should be, here's how you do it. Go to second distribute, binomial CDF. Trials is 10. P is 0.67. X value is 6. So what this is going to give me is 6, 5, 4, 3, 2, 1, 0, which I don't want. I'm going to subtract, the answer from 1. So it will be 1 minus 0.4316. And if you do this, guys, it will be that's part D. So we dealt with exactly, guys. We dealt with at most. We dealt with more than. We dealt with at least. There is one sign that we haven't dealt with. Can you tell me which one is missing? So we did at most, we did at least, we did more than, we did exactly. There's one more. What would that be? Among the 5 signs that we discussed earlier. The less than, which I'm going to add, just one question on less than. And then this problem will cover everything that you need to know in this chapter. We'll give you a break in. Why don't we take a break now? Let's come back at 11:10, guys. Let me stop, pause recording. Resume. So for part E, guys, he's asking you what's the mean of the binomial distribution. You need to memorize this mean or write it down. The mean is always the n, which is the number of trials, times the p, which is the probability of success. It's very, very easy to compute the mean. I never had a student who failed this question, because if you know the formula, you should be easily get the correct answer. My n, guys, is 10. And my p is 0.67. You just multiply the two values, and let's multiply them here. So mean, you write it like this, which is equal n times p. N is 10, and the probability of success is 0.67, and it is 6.7. Standard deviation, again, it's very easy formula. It's the square root of NPQ. And here is how you write it down. Sigma equals, which is square root, which I'm going to show you how to use the square root function, guys. 10 times 0.67. And would a student please tell me what Q is? I know P is 0.67. What would be Q here? Q is a probability of failure. Don't make me put it down, guys. I need students to do this.
0.25.
Not 2.5. Where did you come with the 2.5 is from? The probability of success is 0.67.
0.33.
Yeah, you got it. And you know, guys, how she did that? So Q is 1 minus P. So 1 minus 0.67. They should add up to 1, remember. So it's 0.33. That's good. Okay, here's how you plug it into your calculator, guys. Watch. That's very important. I've had students in the past write the correct formula, but they just don't do, they forget to do the square root at the very end. So here's how you do this. You need a calculator for this. Okay, you press the second key, guys, and then here's the square root under x squared right here. You can see it. And now I have the square root. I enter 10 times 0.67 times 0.33 and enter. And here's the answer. If in my lab stats, he says round your answer to 2 decimal places, it will be 1.49. 3 decimal places will be 1.487, and so on and so forth. Let's now round it to 2 decimal places, so 1.49. Okay, so the mean is n times p, and the standard deviation of the binomial distribution is square root of npq. The last question is, what is the probability that less than 5 of them consider air conditioning a necessity? Okay, less than 5 is this probability of x less than 5. Okay, how do we do this? Less than 5, guys, means 4 or 3 or 2 or 1 or 0. Any suggestion on how we can do all of those in one shot? You guys can find the probability of x equals 4 using binomial PDF. You can do 3 using binomial PDF, 2, 1, 0, and add them up, but there is a shortcut. Would the student be able to tell us? It's using CDF. But CDF on what number? You put the n, you put the p, and any guess what should that number be right here? Not 5. Probability of x less than 5, guys, means the probability of x at most 4. So less than 5 means at most 4. And you can put a 4, because at most 4 means a 4 or 3 or 2 or 1 or 0. Remember, the variable is discrete. There are no decimals. So the number that comes before 5 immediately is 4. And the number that comes below 4 immediately is 3 and 2 and 1. They have to be whole numbers. So if I ask you guys to find the probability of x less than 5, you do a binomial CDF at 4. If I ask you to find the probability of x less than 3, you do a binomial CDF at 2, and so on and so forth. So there will be a 4 here. So less than 5 means at most 4. And at most, guys, we can use the binomial CDF to find it. So let's do this. Second, distribute binomial CDF. That's the formula. 10, and then put 4 here. 0.0732. And that should be your answer right here. Okay. Any questions about part G? Okay. Here is my, I'm going to write a summary, guys, of what we did here. And you can use this to guide you through the chapter 4 assignment, which I'm going to glance through it before we do anything else. So just give me a second here. I'm going to grab a piece of paper. So In any exercise with binomial distribution, he's going to give you the number of trials n, and he's going to give you the probability of success p. And then, if he asks you the first question, guys, what's the probability of x? Exactly a, exactly. Let's say a is 5. Here's how you answer it. You do binomial PDF, and this is what I would like to see on the assignment when you do your work. So for exactly, just put the equal sign, and then you put binomial PDF, you put the value of n, you put the value of p, and you put a, and that's how you answer exactly. And then whatever answer you get of the calculator, you just put it there. If it says round to 3 decimal places, you round to 3 decimal places. 4 decimal places, you round to 4 decimal places. B, probability of x at most a. That's CDF, guys. So you go binom, CDF, you put n, you put p, you put a, and then equal. Remember, they're not the same. This is a P and this is C here, 2 different formulas. Now, C. What's the probability of x less than A? That is how you deal with it. You do binomial CDF. You put n, you put p, and look, guys, this is what we did last thing. Less than 5. We did less than 5 means 4 or less, 4, 3, 2, 1, 0. So we did at most 4. So for this, guys, that's less than 5 means a 4 here. Less than 6 means a 5 here. Less than 8 means a 7. So you just put a minus 1. So that's a 5, you make it 5 minus 1, that's a 4. These are not in the book, guys. These rules are not in the book. I abbreviate them for students. He's not gonna tell you exactly what to do, just like what I'm doing for each question. So you're not gonna find him online. What's the probability of x more than a? And a is the number in the question. X more than 7. Here's what we did earlier. You do 1 minus binom CDF n p a. Assuming that you know how to use the binomial PDF formula and the binomial CDF formula. So look, we did the at most. At most, we write it like this. Less than a, we write it like that. More than a, we write it like this. And there is a last one, guys. We did at most, we did less, we did more, at least now. And at least means greater than or equal to a. And we did it like this, 1 minus binom CDF. So what I'm trying to do here, guys, just show you how to do everything using technology here. If you use your computer, then you don't have to do any of this because they are all, you can do them directly without even having to use those shortcuts. So I'm going to demonstrate another example. So at least a greater than or equal to a, it will be n p a minus 1. And then f, what's the mean of the binomial distribution is n times p. And g, if he asks you the standard deviation of the binomial distribution would be square root of n times p times q. That's the formula. And if you want the standard variance of the binomial distribution is n times p times q without the square root. This is the standard deviation right here. And the variance, guys, is without without the square root. Sigma square is n times p. But I think most of the time he'll be asking you to find the mean and the standard deviation. Any questions about this summary? So this is the summary of section 4.2 and chapter 4. What I'm going to do now, I'm just going to take you to the assignment and show you the questions on the assignment and show you that you can do all of them using those techniques right here. So let's just go there. So we're going to the assignment now. Okay, that's math 141, C1. Okay, chapter 4 assignments. And actually, I did a similar question right here, so you guys can watch the video. But let me just show you the questions. Let me open it. Okay. State whether the variable is discrete continuous. So that should be 1, 2 here. The random variable X represent the number of cars per household in a town of 1,000. What's the probability of randomly selecting a household that has less than 2 cars? Okay, less than 2 cars, guys, means a 0 or 1. So you will find this probability of getting a 0, which is going to be the number of households divided by the total. And then you find the probability of 1, and then you add them up for the 2 probabilities. Number 4, determine whether this is a probability distribution. Remember, there are 2 conditions for the probability distribution. All the values in the probability must be between 0 and 1, and they add up to 1. Well, you notice something not normal here. That's why probably you should say that this is not a probability distribution. Why? Remember, probabilities are positive between 0 and 1, and they add up to 1. Number 5, find the mean of the probability distribution. We did work on the formula, guys, for the probability distribution. I think let me just write the formula down to remind you again. That's the formula. Sum of x p x. So you just take 0 multiplied by 0.07 plus 1 times 0.68, and then so on, and you add them. And then we go to the last question, which is the one that I've been talking about here. We did in section, that's section. So the first 5 questions, guys, are mainly section 4.1, and this is 4.2 right here. A recent survey found that 72%, so that's a probability of success P. I'm gonna give you this hint here. Of all adults over 50 wear glasses for driving. In a random sample of 9, that's N. What's the probability that exactly 6 of them wear glasses? You guys, if you go to the last page that I did, that was part A. So just follow whatever we did and part A and the last page of the guided notebook. We need a probability of X equals 6. That's PDF. What's the probability that at most 5? That was part B, guys. I did at most 7. You just follow that and just change the 7 to 5. And at most means less than or equal to 5. What's the probability that at least 6? I did that in part D of the last page. At least means greater than or equal to 6. And then what's the probability that none of them? What is none, guys? What does that mean? X equal to what? To 0. So that's exactly, again, so it's the same thing. What's the probability that X is exactly 0? And you can use the binomial PDF here. And you can see, guys, the last two questions. What's the mean of the binomial distribution, which is n times p? And what's the standard deviation of the binomial distribution? As you can see, the formula is square root of n times p times q. And you just do this exactly similar to how I did it. And you can use the yellow sheet that I just produced to guide you through it, or you can use the example that we did before I did the yellow sheet. Any questions about this assignment? Okay. Now I'm just gonna stop